Next type of example is we're going to do is what we call the word rationalizing denominators. So watch what happens when we do letter A. If it says simplify, once again, we're simplifying roots. Okay, roots. So remember our property, if we have the square root of a whole fraction, we can break it up. Square root of 15 on top, square root of 2 on the bottom. And then I look to say, okay, can I break down square root of 15? Square root of 3, square root of 5. But that doesn't do anything for us. We can't, even if you put square root of 3, square root of 5, that doesn't simplify. Like, these don't break down anymore. So really the best answer is actually square root of 15, like, because these don't break down. So we just leave it, square root of 15 on top, because they don't break down, over square root of 2. Does square root of 2 break down? No. So some people would say, oh, this must be our final answer if these two don't break down. No, because the simple fact that you cannot have a square root in the denominator as a final answer. Okay? So write that down. You can't have a root in the denominator as a final answer. So this cannot be your answer. This can't be your answer because there's a root in the denominator. This can't be your answer because there's a root in the denominator. So that's why what we call is rationalizing. What does that mean? We're going to make, what is square root of 2? Square root of 2 is irrational, right? We're going to make square root of 2 rational by doing something to it. All we have to do is multiply it by something. So if we multiply root 2 by something, the root goes away. You should already know this. Root 2 times root of what? By itself. Root 2 times root 2 gives you a whole number. But if I multiply root 2 to the bottom, I got to multiply root 2 to the top, right? So if I multiply root 2 times root 2 on the bottom, what do I get on the bottom? A whole 2. I just made it from irrational now to rational. 2 is rational. What is on top though? Square root of 15 times the square root of 2, which makes it square root of 30. Now, we might be done, but you always have to check, is that the lowest form possible? What is square root of 30? Square root of 2, square root of 5, and square root of 3. Those are all prime. Those can't break down. So yes, this is good. Over 2. So that's fine. And you can't do 30 and 2 and cancel out. No, that's in a root. That's not. So this is your final answer. That's good. Okay, so this is called rationalizing. When you multiply by something to rationalize denominator. Notice what I really multiplied by. What did I really, here's my fraction. What did I really multiply by right here? Square root of 2 over square root of 2 is really equal to 1. I really took this fraction and multiplied by 1. Okay, so it really doesn't change the value of the fraction. It just changes the look of the fraction. Okay, so that's what rationalizing is. But here's the tricky one that people don't get. 3 over 7 plus root 2. Well, I want to get rid of this root 2. I can't have a root in the denominator. So some people say, oh, just multiply by root 2. But think about that. If you took this and multiplied by root 2 here, I would take root 2 times this, but I would also have to take root 2 times this thing, which would mean the root is still there. Okay? So here's what you have to do. You have to multiply by 7 minus root 2. You recognize this? 7 plus root 2, 7 minus root 2. That's a difference of squares. A plus b, a minus b. What is this guy called? If you started with 7 plus root 2, 7 minus root 2 is called the conjugate. Alright? The conjugate. So, if I start with 7 minus root 2, I would actually multiply by 7 plus root 2. These two things have to be opposites. Okay? So, when you multiply them, the roots actually go away. You'll see what happens then. If I multiply 7 minus root 2 on the bottom, 7 minus root 2 on top. Okay? Let's start multiplying. Let's do the bottom first. What's 7 plus root 2 times 7 minus root 2? A binomial times a binomial. You FOIL. 7, 7, 7 root 2. So 7, 7 becomes 49. 7 times minus root 2 becomes minus 7 roots of 2. Can't put those together, right? Let's do the inside. This one and this one is plus 7 roots of 2. See what happens there? And root 2 times negative root 2 becomes, root 2 and root 2 is 2, but plus and a minus make a minus 2. Here's where people mess up. Root 2, minus 2. Now that's the bottom. Look at the top. That's this times this, so I'm going to distribute this. 3 times 7, 21. Minus 3 times root 2 is just 3 roots of 2. Remember, don't multiply 3 and 2 and make 6. Can't do that. Equals. Look at the bottom. See this right here? Plus 7 roots of 2 minus 7 roots of 2. Guess what happens? It cancels. That's nothing. So that's why what happened, every time you multiply by the conjugate, the roots will cancel out, and you're left with just 7 squared, which is 49, and square root of 2 squared is 2, but there's a minus here. So look what you're left with, 49 minus 2, which is 47. These are one of the most missed problems right here. 21 minus 3 roots of 2. There's your final answer over 47. I always check though, can I simplify this? No, I'm good. Check. Done. Alright, that's